everyone. I'm Paras, a pre-final year student of Bharati Vidyapeeth's College of Engineering, Delhi. I started my journey with SmartBridge as a machine learning intern in the month of May. I learned a lot here, and the mentors here were really helpful, which helped me to complete my project. I was allotted the project predicting life expectancy using machine learning. So let me start with the video demonstration. All my codes are uploaded to the GitHub. Let me first show you the dataset. This is the dataset. There are total 22 columns. I ignored country, year and status in the prediction. Life expectancy is the predicted column here, and all other here are used to predict the life expectancy. This and Let me take you to the platform first. This is the platform where we worked. This is a smart interns platform. This is the dashboard where all your internships are visible. This is my internship section where I have a project's life expectancy using machine learning. This is my workspace basically. I have completed all the tasks and they are under review section. As you can see, some of them are reviewed and some of them are still under the review section. And these are the stages basically which I was to follow, and this is the project planning, exploring cloud, creating and exploring some Watson services, introduction to Watson Studio. I'll come back to this. Predicting life expectancy with Python and predicting life expectancy without Python. I did both of them, and both of them are demonstrated in the video as well. These are the three sections: GitHub, writer part, and Slack channel. GitHub is where all the project codes were uploaded, and this is the writer part where the project scope was written. This writer part I have opened here, and this is the project scope basically, the project summary, requirements, functional requirements, and technical requirements, software, project deliverables, teams. It was an individual task and project schedule basically. So let me start with the let me move on rather to the IBM cloud part where all our work was done. Cloud is where we learned a lot. We were taught by our mentors, and the Slack channel was the doubt resolving sections. Mentors were available 24 hours for us, and all the doubts were cleared. So there are some of the services I have created and I have used in the project. Two of them are Node-RED and IBM Watson. I used Watson Studio and Node-RED in the project. Firstly, Watson Studio, which allows you to create ML-related tasks and models with some great features like Auto AI. Here you can see as I, as there are many services associated with my account. Let me take you to the Watson Studio where I worked and created a Jupyter file both for the Python part and for the Auto AI part separately. Here there are some of the projects, two of them I built using the internship and others also were taught to us by the mentors. Predicting life expectancy using Python. This is the first task or rather the first type. This is the dataset importing and then the life expectancy with Python. Let me take you to the notebook. So these are my cloud credentials. So I'll be moving ahead. I created a data frame, printed some of them, five of the first rows describing the dataset, getting information of the dataset, and checking if there are null values. There are many null values in the dataset, so I had to fill them with the mean of those columns, which is being shown on the screen. Then I checked again, there was no null column left, then plotting those values. Then I used four algorithms. This is basically a regression task as the Life expectancy values is a continuous variable, and so I've used four regression algorithms while dealing with the Python part. First of them is linear regression. I use linear regression and kept my data, Y data into the life expectancy and X data, all the data set except life expectancy, country, year, and status. Then I splitted the data and then I fitted my linear regression model and I tried to get some values. These are the predictions, and I was getting an accuracy of 78.3 through the linear regression model. So I moved ahead with the standard vector machine, support vector machine or SVM. Firstly, I used standard scaler to normalize my values, then splitted the data again. Then I fitted the data using SVM and predicted. On the train portion, it was giving an accuracy of 85.5, which is really good. And the test portion also, it was giving an accuracy of 81.3, which is again a good one. As compared to the other algorithms, I used the ridge regression algorithm. It gave me accuracies of 82.8 and 78.3 on train and test part respectively. Then I used lasso model. It gave me an accuracy of 82.8 and 78.2 respectively. Then I created the model. These are the model creation steps: credentials, model parts, model name, email, and the project name. This is my scoring endpoint which I used in the Node-RED flow. So let me take you to the Node-RED flow now. Node-RED is basically based on Node.js, wherein you can integrate your backend with the front end with the help of creating simple nodes. And this is a very useful task. This is basically where my entire backend part was connected with the UI part. These are the nodes. Firstly, I got the form values here, labels, names, and types of those form values. As you can see, I have not included those three columns which I dropped during the model creation. Then I deployed it and checked the UI part. This is my UI part. I kept all my values low in order to get a high prediction of life expectancy. You can check the dataset. These values are really low. So my life expectancy is coming out to be 120.57. If I predict it this way only, this is coming out to be 120.57, and you can check that in the debug part also. 120.57 is the value. These are the nodes. In the pre-token part, I am getting those form values which I will be sending to the model through the HTTP request node. I am sending those form values which I have obtained in the previous part. Then this is a send to endpoint wherein I am getting those values and sending it to the model for the life expectancy prediction. This is the fields part wherein all fields are there and respectively all the values are kept here. Then these values are sent to the HTTP request again, this time to post the model predictions, and I was getting those values in the debug as well. And for the UI part, I use message.payload, which is default syntax of Node-RED, and then the UI part, as I showed you, the prediction is available both in the UI part also as well as in the debug section also. So this was all about my life expectancy prediction with Python. Now I'll be showing you the life expectancy project without Python, which I have also used in this internship. Let me again take you to the Watson Studio so that I can launch that easily. These are all the services associated, and let me go to the Watson Studio again. Getting started with the Watson Studio, and Auto AI is a great tool to use if you don't know any programming language or so. It gives a really good accuracy and comparison of all the algorithms present. This is the Auto AI experiment, and this is the models I have been dealing with life expectancy prediction with Python, which I showed you just now, and this was the extra trees regressor estimator. So it is a regression algorithm again. It gave me an accuracy of 96%, which is really, really good. So this is my model built, and this is my deployments. I have already deployed it, and this is something. So to the deployments part, I can check my service endpoint here, and I just need to edit the service endpoint and some syntax values in the node-RED. This is the test part where I can check for the values here. This is the implementation part where I get the scoring endpoint. And to the node-RED, let me first disable this flow as I don't need the Python part now. So I have disabled it, and let me move on with the life expectancy without Python flow. I'm enabling this. Earlier I had worked with it and disabled it in order to get that UI. It is the same UI except I have to change the scoring endpoint here and some of the syntax. For the auto AI part, I have included all the columns of the dataset, country, year, status also. But as you can see, these are not required values. You can skip that, and our model will be evaluating only the remaining of the algorithm, of the columns. So I've included A, B, and C as the values as I have been given. I have given that UI form some extra values. And the syntax part for the send to endpoint node. For the auto AI part, you have to give data in the form of input data. So some syntax variations, rest both the flows are. Let's move now to the auto AI UI part, which I have already deployed, or let me deploy it again. So this is the UI part. As you can see now, there are country, year, status options also available. Let me fill it as, say, Afghanistan, and here as 2015, status developing. Then I'll get the values similar to those of the first row of my Excel data in order to check how accurately my model is predicting those values. Adult mortality was 263, 62 as you can check with the data set, 263, 62, 0.01 and so on. So I'll be moving with it 0.01, 71.27, then 65, measles level was 1154, and then 19.1, under 5 deaths there were 83 under 5 deaths, and the polio level was 6, total expenditure as 8.16, then 65 was the diphtheria level, HIV AIDS as 0.1, let me confirm it, HIV AIDS as 0.1, then 584.25, 33736494. This is the population. Then thinness 1 to 19 years 17.2. Then thinness 5 to 9 years 17.3. And then income composition of resources at 0.479. And schooling level it's 10.1. So I predict it, and let me see, my model is giving me 63.97, and let me check it, it's 65. So it's really accurate as the approximate value would be 64 according to the model, and 65 is the real value. So my model is really predicting well, and this was the demonstration of the auto AI part also. And I'll thank all my mentors who supported me really well and guided us, guided me and other members of the internship through the Slack channel. That's all for the project demonstration part. All my files are uploaded to the GitHub. Thank you so much.